Take a look at the surfaces of Pluto, Charon, and Neptune's moon, Triton. You'll notice that they are all stained in some way with a red or yellow hue. But why?
This mysterious substance isn't rock or rusty iron as we see on Mars. It's something completely different and far weirder. It's a sticky, complex, cosmic gunk that is entirely organic. And it might just be the missing link to how life started on Earth and how it may have started elsewhere in the solar system.
Hi, I'm Rob, and welcome back to V101 Space.
The bizarre substance is called Tholins, and when you first see it, it almost looks like cosmic graffiti sprayed across certain moons, dwarf planets, and asteroids throughout the solar system. Just like spray paint can coat the bland walls of a town or city in vibrant colours, Tholins act as a natural pigment that stains and colours the frozen surfaces of certain worlds. I mean, take a look at Pluto's Cthulhu Macular region, a giant, dark reddish-brown patch stretching around the equator. You can hardly miss it. It's magnificent. But it's not the work of a giant cosmic Banksy. So what's causing this colourful phenomenon?
Well, to understand what Tholins are, we have to travel back to 1979.
Long before New Horizons, the legendary astronomer Carl Sagan studied the strange orange fog hiding the surface of Saturn's moon, Titan.
He decided to build a simulated alien world inside a glass jar. Basically, he filled a flask up with the exact gases found on Titan, methane and nitrogen. Then he blasted it with electricity to simulate the impact of solar radiation and cosmic rays.
These are different types of energy shot out from the sun and the stars into space.
Day after day, the gas began to change. A thick, sticky, reddish-brown residue began coating the inside of the glass.
Because it didn't exist naturally on Earth, Sagan had to invent a new word for it. He named it
Tholin, from the ancient Greek word for muddy.
This is what can be seen stained across Pluto, the North Polar cap of Charon. It is possibly what is highlighting Europa's cracks. And take a look at the Kuiper Belt object Arrokoth, which was visited by New Horizons in 2019, 4 years after passing Pluto. It's a 36-kilometre long, snowman-shaped, primordial object that is completely coated in these reddish-brown tholins. Other dwarf planets that we haven't visited yet, such as Makemake or Sedna, also appear to be covered in a reddish-brown hue. And tholins have even been detected in the dust disk surrounding the young star HR 4796A, which is about 240 light-years away, and is only about 8 million years old. It's a brand new star compared to ours that has planets forming around it as we speak, with this bizarre substance mixed in.
Just as Sagan's atmosphere in a glass jar experiment showed, the same reaction is happening on a planetary scale, even a stellar system scale. Tholins seem to be abundant across the galaxy. So what is happening? And what actually is this stuff?
Well, when simple carbon-containing gases like methane are hit by an energy source like UV light, the radiation breaks the bonds of the molecule, triggering a chain of chemical reactions. When this happens a lot, they grow larger and heavier, clumping together into microscopic haze particles. Over millions of years, this cosmic haze slowly drifts down from the skies of worlds like Pluto. It literally snows a sticky, tar-like material across the icy plains, staining many of the icy white worlds of the outer solar system a red, brown, or yellow.
But this story takes a wild turn, because you may have noticed I've been describing tholins as organic throughout the video. And organic means living. right?
When modern researchers dissolved laboratory tholins in water, they didn't just find random carbon sludge as they expected. They found amino acids, the literal building blocks of proteins, an essential chemistry required for all known life. This means the red stains we see all over the outer solar system isn't just space gunk. In a way, they are chemical cradles. And although tholins aren't alive like me or you, or even like bacteria for example, they could have been the critical catalyst for the start of life on Earth. They are referred to as organic because they are related to living matter. It is possible that early Earth was flooded with tholins, either through lightning reacting with the rich methane atmosphere that once covered Earth billions of years ago, or via impacts from comets and asteroids that were already coated in tholins. We know they exist because we saw them all over Arakoth.
And when water began to form on Earth's surface, just like in the laboratory tests, tholins dissolved, breaking down and reorganizing into vital biological compounds, a process called hydrolysis.
Tholins may have even protected the first life from the early sun's intense radiation. Billions of years ago, the sun actually emitted far higher levels of extreme UV light, and Earth lacked a protective ozone layer because there was little free oxygen in the atmosphere back then. But there was possibly a thick covering of tholin haze, something like what Saturn's moon Triton looks like today, perhaps.
And early life may have even eaten tholins. It could have been the first food source before life evolved the ability to make its own food via photosynthesis. In fact, it's been found that modern microbes can successfully eat tholins and use them as a primary carbon food source. So I suppose the next natural question is, if tholins are the catalyst for life on Earth, and we can see it staining the surfaces of so many worlds in the outer solar system, does that mean life could have started on one of those worlds as well?
Well, we haven't found life beyond Earth yet, but I think it must heavily increase the odds that it is out there. Not on the surfaces of any of these worlds, it's simply far too cold for life as we know it.
As we have discovered, to create that chemical pathway to life, tholins require liquid water and energy. The surface of Pluto, for example, is minus 240 degrees Celsius, far too cold for water to flow. But what about below the ice?
Let's focus on Europa as an example. The icy moon of Jupiter is covered in enormous red cracks streaking around its globe. It almost looks broken, right? But that might actually be a reason why life could exist there.
Now, the main hypothesis for Europa's red-stained cracks is that hydrated salts from a hidden ocean below the ice have been chemically altered by Jupiter's intense radiation.
Basically, ocean salt rises and seeps up through the cracks to the surface as Europa is squashed back and forth by the gravity of Jupiter and the passing moons Io and Ganymede, as Jupiter bombards Europa with high-energy particles.
This heavy radiation essentially cooks the salts, turning it this reddish-brown colour. But there is another hypothesis.
Rather than cooked salts, could it be tholins in those red cracks? Europa experiences anything from 100 to 1,000 times more radiation than the planets in the inner solar system, meaning that if the starting ingredients for tholins are present in the surface ice, rather than floating in the air, ice tholins could form through a process called solid-state radiolysis.
Essentially cooking tholins right there on the surface.
New planetary models show that Europa's heavily fractured, 20-kilometre thick ice shell acts like a slow conveyor belt, allowing these heavy, nutrient-rich tholins that might form on the surface to slowly sink into a global liquid ocean that holds more water than all of Earth's oceans combined. Deep in this ocean, where it is permanently dark, these space nutrients can mix with warm, volcanic hydrothermal vents on the sea floor to create the perfect recipe for a prebiotic cosmic soup. A mystery NASA's Europa Clipper spacecraft can investigate when it arrives in April 2030. What a moment that will be.
But Europa isn't the only world hiding this secret.
Saturn's moon, Triton, as we have already discovered, has an atmosphere full of tholins, and likely has a subsurface ocean of water as well. Neptune's moon, Triton, has tholins on its surface and may have a secret ocean too. The same goes for Pluto and possibly many other dwarf planets. This cosmic gunk isn't just a stain on the surface. It is an active chemical factory waiting to be switched on.
But what's fascinating is that if life is discovered in the subsurface oceans of the outer solar system in the next decade, it likely will have elements of deep sea Earth life, but also look completely different.
Can you imagine what they look like? Any life down there wouldn't have eyes. No light can penetrate the ice shell into the ocean. Their skin would likely be translucent, as camouflage from light is unnecessary. They might have some kind of antifreeze in their systems to stop them from freezing. Larger creatures might have long feelers to find food or a mate in the pitch black. Smaller organisms would need to feed on minerals from hydrothermal vents instead of sunlight like on Earth, a process called chemosynthesis. And they would likely move slowly to save precious energy while swimming. You can really let your imagination run wild. For decades, we have looked out into the freezing, hostile void of the outer solar system and assumed it was completely dead, a barren wasteland of frozen rock and ice.
But the truth is the exact opposite. The cold emptiness of space is actually a massive chemical factory, churning out the raw components of biology every single day. Does that mean life is out there?
Only time will tell. But when we are discovering environments like the ocean under Europa's ice shell that is possibly mixing with tholins, well, the odds certainly must go up.
Life doesn't appear from nowhere. Before biology comes chemistry, and tholins may represent one of the missing steps. They aren't life, they don't prove life, but they may provide part of the ingredients for life. This channel is researched, written and narrated by me, a real human who actually checks sources and cares about the stories behind each video. That's why I created the V101 Alliance, a membership offer that for less than the price of a coffee each month allows people who values this kind of content the chance to support it directly, and in return get meaningful perks. So if you'd like to join this mission and become a part of the V101 Alliance, become a member today for just $2 by clicking the join button that's located next to the subscribe button. I would love to welcome you, and hopefully I'll be seeing your name in one of my future videos very soon.